Last chapter we studied trigonometry. In this chapter we studied Unit 3 Unit 3 Coordinate system. Coordinate system. First upon, what is coordinate system? First upon we give inclination of a line. Inclination of a line. What is inclination of line? The smallest non-negative element theta is called inclination of the angle. Suppose here this theta lies between 0 degree and 90 degree, and suppose here this theta lies between 90 degree and 180 degree. So inclination of x-axis is 0 degree and inclination at y-axis is 90 degree. So then we give the formula of slope of line. Slope of a straight line. Slope of a straight line. How to find out slope of straight line? Slope of m is equal to tan theta. Means, for example, suppose if theta is equal to 30 degree, then slope m is equal to tan theta. Means tan theta is equal to tan 30 degree, and tan 30 degree is equal to 1 tan 1 upon root 3. And if suppose theta is equal to 45 degree, then how to find out slope? Slope m is equal to tan 45 degree, and tan 45 degree is equal to 1. Then if theta is equal to 135 degree, then m is equal to tan 135 degree, but 135 is the 180 minus 45 degree, and hence tan 180 minus theta, tan 180 minus theta, tan 180 minus theta is equal to minus tan theta. Hence we get minus tan 45 degree is equal to minus 1. Then we give the next point. Slope of a line. Slope of a line passing through passing through 2 points, two 2 points, 2 points, A x1 y1 and B x2 y2. Suppose first upon we draw this diagram. This is P, this is Q, and this is A x1 y1 and this is B x2 y2. Then this distance, this is C, this distance is y2 minus y1 and this distance is x2 minus x1. Hence this is x-axis and this is y-axis. Then first upon given in right angle triangle AC is equal to x2 minus x1 and BC is equal to y2 minus y1. Then slope of tangent M is equal to tan theta, but tan theta is equal to opposite side upon adjacent side, but here opposite side is BC and adjacent side is AC. So here we get BC is equal to y2 minus y1 and AC is equal to x2 minus x1. Hence is equal to difference between, this is the difference between y coordinates and this is difference between x coordinates. Then suppose slope of line, then we give next point slope of general form, of a line x plus by plus c is equal to 0. Suppose here slope of line ax plus by plus c is equal to 0. Then we get slope of line is m is equal to minus coefficient of x upon coefficient of y. Hence here coefficient of x is a, so minus a upon coefficient of y is b, so minus a upon b. For example, slope of line 2x plus 7y minus 5 is equal to 0. It's minus a means minus 2 upon minus 2 upon minus a upon b, so minus 2 upon 7. And this is first example. Then second example is slope of line 2x minus 7y plus 4 is equal to 0 is minus a means minus 2 upon b means minus 7, so minus 2 upon 7. But minus 2 upon 7 is equal to 2 upon 7 because minus and minus get cancelled. Then we get next theorem. Next point is angle between two straight line. Angle between two straight lines. Angle between two straight lines. First upon we give theorem. If M1 and M2 are the slope of two lines, such that M1 into M2 not equal to minus 1, then the measure of the angle between the two lines is given by tan theta is equal to mod of M1 minus M2 upon 1 plus M1 into M2. Then we give the proof of this theorem. First upon we draw this diagram. Here this is B, A, this is theta and C, A, B and C. Then this is x coordinates and this is y axis. Then this is theta 2, this is 90 degree, this theta. This is theta 1. Then considering two intersecting lines, this is L1 and L2. Then the inclination of line M1 is given by M1 is equal to tan theta 1 and M2 is equal to tan theta 2. Then let M1 intersect the x-axis and M2 intersect the x-axis at B. Then here theta 1 is equal to theta plus theta 2 because by exterior angle theorem. By exterior angle theorem. Hence, theta is equal to theta 1 minus theta 2. Then taking tangent on both side, then taking tangent on both side ला tangent पुट केला तर tan theta is equal to tan theta 1 minus theta 2. But we know that tan A minus B is equal to tan A minus tan B means tan theta 2 into 1 minus tan theta 1 into tan theta 2. But tan theta 1 is the m1 and tan theta 2 is the m2. Hence we get tan theta is equal to m1 minus m2 upon 1 minus m upon 1 plus m1 into m2. As theta is acute angle, hence tan theta is always positive. Hence we get tan theta is equal to mod of this m1 minus m2 upon 1 plus m1 into m2. Then we give next point, condition for parallel and particular line. Condition for parallel and perpendicular line. Perpendicular line. Here first condition is condition for parallel lines. For two lines to be parallel. Lines parallel असतील तर what is condition for two lines to be parallel? So first upon what is parallel lines? So we draw this diagram. This line is called parallel lines. This line is L1. This line is considered as L2. Then two lines parallel. Two lines are parallel if their slopes are equal. Slopes are equal means m1 is equal to m2 and converse is also true. So first upon we give tan theta is equal to, suppose theta is parallel lines angle 0 असतो, so tan theta is equal to tan 0 degree is equal to tan 0 is equal to 0. Hence we give tan theta is equal to m1 minus m2 upon 1 plus m1 into m2 is equal to 0. Then we get m1, this mod side cancel, and 1 plus m1 into m2 is equal to 0. Hence we get m1 into m2, m1 minus m2 is equal to 0. Hence m1 is equal to, here we get plus sign, m1 is equal to m2. Thus two lines are parallel. Hence thus two lines are parallel if and only if their slope m1 is equal to m2. Then we give second condition for perpendicular lines. Second condition for two lines to be perpendicular lines साठी कोणती कंडिशन perpendicular. Suppose we draw this diagram. First this and this is 90 degree, and this is theta 2, this is theta 1, this is x-axis, this is y-axis. Then each point A, B and C. Then first upon we give, this is L1 and L2. L1 and L2 are two lines with inclination theta 1 and theta 2. Then L1 is perpendicular to L2. Then in triangle M, major angle BAC is equal to 90 degree. First upon slope of L1 is equal to M1 is equal to tan theta 1, and slope of L2 is equal to M2 is equal to tan theta 2. Hence in triangle ABC we give exterior by exterior angle formula, angle theorem. Theta 1 is equal to 90 degree plus theta 2. So first upon taking tangent on both side tangent, then we get tan theta 1 is equal to tan 90 degree plus theta 2 plus tan 90 degree plus theta is equal to cot theta. Hence we get tan theta is equal to cot theta 2. Since tan 90 degree plus theta is equal to cot theta. Hence we get, but cot theta is equal to 1 upon tan theta, minus cos theta, and minus 1 upon minus cot theta and minus 1 upon tan theta. Hence this and this will get multiplication. Tan theta 1 into tan theta 2 is equal to minus 1. But we get tan theta 1 is the m1 and tan theta 2 is the m2. Hence m1 minus m2 is equal to minus 1. Hence two lines are perpendicular if m1 into m2 is equal to minus 1. Then third condition prove करायची. Then third condition is, if two lines are perpendicular then the angle between them is of 90 degree. Then suppose first upon given cot theta cot 90 degree is equal to 0, but cot theta, we know that cot theta is equal to 1 upon tan theta is equal to m1 minus m2. Here get m1 minus m2 upon 1 plus m1 into m2 is equal to 0. Hence we get this is equal to 0. Mod is cancelled. m1 m2 m1 minus m2 is equal to 0. Hence we get 1 plus m1 into m2 is equal to 0. Hence we get m1 into m2 is equal to, here plus sign, here with minus 1. Hence when two lines are perpendicular, thus the two lines, then the product is minus 1. Then we give some formulas. First, if two lines are parallel, then m1 is equal to m2. And second is, if two lines are parallel means are perpendicular असतील तर then m1 into m2 is equal to minus 1. Then third formula is, if m1 and m2 are the slope of line such that m1 into m2 not equal to minus 1, then angle between two lines is tan theta is equal to mod m1 minus m2 upon 1 plus m1 into m2. Hence Then we give the first example. Find the slope of a line. Find the slope of a line whose inclination is 60 degree. 60 degree means first upon given inclination means theta. Theta is equal to 60 degree. Then slope of a line formula is slope of line is equal to m is equal to tan theta, but theta is 60 degree, so tan 60 degree is equal to root 3, and slope of line is equal to root 3, and slope of line is root 3. Then we give second example. So inclination is 5 pi radian upon 60. Then we convert this into degree. So pi means 180. 5 into 180 upon 60. 5 upon 6. So 6 3 etc. So we get 150 degree, and slope of m is equal to tan theta, but tan theta is 150 degree, and 150 degree is 180 minus 30 degree, but since tan 180 minus 30 degree is equal to minus tan theta, tan 180 minus theta is equal to minus tan theta, hence we get minus tan 30 degree, but tan 30 degree is 1 upon root 3, hence slope of given line is minus 1 upon root 3. Then we give second example. Find the slope of a line through points -1, -2 and -3, -8. First upon given that this point given a x1 y1 is equal to -1, -2, and a and b x2 y2 is equal to -3, 8. Hence we know that slope of a line passing through point through points -1, x1, y1 and x2, y2 is slope m is equal to y2 minus y1 and x2 minus x1. Hence we get slope of a line passing through point -1, -2 and -3, 8 is m is equal to y2 minus y1, means here y2 minus y1, 8 minus 2, and x2 minus x1 means -3 minus -1, 3 minus -1. Hence we get 8 plus 2 upon -3 minus plus 1. 8 plus 2, 10, -3 minus 2. Hence we get -5. Hence we get slope of line is equal to -5. Hence slope m is equal to -5. This answer. Then we give third example. Find k if the slope of a line passes through 2, 5 and k3 is 2. First upon given x1, y1 is equal to 2, 5 and b x2, y2 is equal to k3. Then given slope m is equal to, here slope is 2. Then slope of line is m is equal to y2 minus y1 upon x2 minus x1. Hence we get m is equal to 2 and y2 minus y1 means 3 minus 5 upon x2 minus x1 means k minus 2. Hence this and this multiplied, 2k minus 2 is equal to 3 minus 5 minus 2. Hence we get 2 into k, 2k minus 2 into 2, 4 is equal to minus 2. Hence we get 2k is equal to minus 2 plus 4. Hence we get 2k is equal to plus 2. Hence k is equal to 1. 2 upon 2, 1. So we get k is equal to 1. And find k. So k is equal to 1. In next chapter we give other example of this type.